Hey folks, and welcome to another demo of isorun. For those who don't know what isorun is, it's embedded V8 directly in Ruby. And isorun is built to be used with Ruby on Rails. So it kind of helps you to run any JavaScript application directly in your Ruby processes, and it makes it really easy and convenient to use JavaScript in a Ruby on Rails application. I originally built this just for the purpose of server-side rendering of few applications or multiple few applications, and obviously React. And it supports some advanced features like intercepting network calls and directly forwarding them to a Ruby method. And then you could take the response and serve the server-side rendered application without any additional network overhead. But today I want to show something that is going a bit beyond server-side rendering and kind of like explores the possibilities for isorun that has nothing to do with server-side rendering. So Nela and I have built this website a couple of years ago, which takes your activity data from a platform like Strava and generates nice looking posters out of it. So when you log in here and you import your data, you can generate like all sorts of posters. Like after you run a marathon, you might be able to print the track. If you want to see all the GPS tracks of your runs over the last year, or your hikes, you can do all sorts of stuff. And I was thinking, when we built this service, or when we built this platform, we had to build like 3 projects: one Rails project with a GraphQL API, one React front end, and then we also needed this poster generator service, which is capable of producing like nice looking images based on data. And back then we used Node.js in a combination with GSDOM and D3. And I recall like this was super annoying. Like running 3 services instead of one was annoying. Building like multiple projects and having all the network overhead was not a lot of fun. So today I want to demo how isorun can completely replace the poster generation service, and therefore I re-implemented this dots poster in isorun. And I want to show you how this looks like. So it's a bit of a simplified version, but I don't have time to build everything from scratch. And I'm starting my Rails application here. And besides the JavaScript and the CSS watch task that are kind of like rebuilding assets for the asset pipeline, there's only the Rails process that runs. And when we open this, we see like this, what looks like an image, but it's actually an SVG directly rendered in the browser. And if we inspect it here, we can see like the network returning the Tailwind CSS file and the font and so on and so on. But when we look into the actual document, we see like there's an SVG here that is returned by Rails. And this is kind of interesting because how do we do that? It's just a Rails application. There's no Node.js. There is no D3 that is running here. And the way this is done is we have a single controller with a single action index, and we can create a new isorun module here that points to an asset bundle called service. So when we go into the application, look into the JavaScript folder, we do see indeed a service JavaScript file. And when we open it, we see there's like a default export that returns a function, a generate function which takes 3 arguments, and then there's a bit of like D3 code, and at the end we return like the HTML, which is in our case an SVG string. And then we store this in an instance variable. When we look into the view here, we see we use that instance variable and additionally call HTML save in order to actually see the result and not getting the output of the encoded string, but instead we want to actually want the SVG to be interpreted. And that's all you need. Like you create the JavaScript file, a bare bones Rails application with any literally any JavaScript bundler you want, as long as it produces into the assets built folder, and you're good to go. But what is kind of like interesting here is the arguments that are passed from Ruby without any special serialization format or whatever, and then we cannot receive this data in the JavaScript world without any issues. And the reason why this is possible is because isorun automatically converts Ruby values into V8 values every single time we call the application. And at the same time, let's just do a demo here. So let's replace the highlight color, which is the color of the dots. And let's reload. It's getting red. And if I turn it back, it gets into the previous color. Another thing that is kind of important during development of such a service is like, okay, this is fine, this is nice, but what happens if I change code here? Like, what if I change the size of the dot positioning or whatever? Let's do, I don't know, divided by 14. Oh yeah, we actually see a change here. Like the dots are now overlaid. This looks pretty cool, by the way. I should use this as an effect. But how does this work? Like, how does the server know that this JavaScript file has changed? And this is pretty simple. We utilize, in the development environment, we utilize the modification time of the file of a bundle to force a reload of the bundle in the V8 VM. If we don't have any changes here, we fully rely on the V8 cache, and this is why this rendering here is super fast, because we have like the hot, we use like the result of the optimized compiler in V8, and we can like fully benefit from the speed of V8. So that's it. This is how isorun can be used for stuff that has nothing to do with server-side rendering, and I'm looking forward to show you more cool demos in the future. Bye-bye.